In our mathematics physics 8, today we are going to revise some formulas that we studied in the earlier classes. In the first one is circle. Now, if you take this circle will have some radius. The radius of the circle is given by r. For a circle, we can find out circumference, also known as perimeter. So the circumference of circle is given by 2 pi r. The formula is 2 pi r. And next one, area of a circle. A is given by pi r square. Now, if we take a sphere, for a sphere, when the name is not mentioned, students, always you take the sphere as a solid sphere only. So this is a solid sphere. And here, this is entirely filled here. This is a solid sphere. Best example for sphere is a cricket ball, or our earth is also a solid sphere. So this is the solid sphere. Now what are the formulas for a solid sphere? For solid sphere, the first formula is, if the radius of the solid sphere is given as r, and here we can find out two values. The first one, surface area of solid sphere. Surface area of the solid sphere is given by 4 pi r square. This is the surface area of solid sphere. And the volume of a solid sphere, V, is given by 4 by 3 pi r cube is the volume. But students, sometimes in some problems, instead of radius, they may give the diameter of this solid sphere. And the diameter is given, the same volume can be written as 4 by 3 pi. Radius is half of the diameter. So you can write d by 2 whole cube, 4 by 3 pi, d cube by 8, 4 ones, 4 twos. This will become 5 by 6 pi d cube. In general, the radius will be given, and we will use this formula so many times in physics. This is the most important formula here. That is, volume of sphere is 4 by 3 pi r cube. But if diameter is given, it will become pi by 6 pi by 6 d cube. This is not required. Pi by 6 d cube. The next one, spherical shell. For spherical shell, we use the same diagram. Diagram will be similar to this one only. This is the spherical shell. Hollow sphere, also called hollow sphere. So in this case, we will write radius of the spherical shell. Let me take this as r. And here also surface area of solid sphere. This is a solid sphere or simply sphere or hollow sphere like this. Here the surface area is given by, here you take a spherical shell with the inner radius and outer radius. Let us say this is a spherical shell. Spherical shell of inner radius r, and one more spherical shell Now, if the inner radius is R1 and the outer radius is R2 and this is a hollow spherical shell, so this is only filled with material and only this area, this volume is filled, then the volume of a spherical shell is given by, this is volume of a hollow spherical shell. But if it has two radii, inner and outer, then the volume is given by 4 by 3 pi R2 cube is the total volume of this entire sphere minus this inner volume, because this is empty space, I have to remove this, minus 4 by 3 pi R1 cube. From this, the volume of this sphere is given by V is equal to 4 by 3 pi R2 cube minus R1 cube. Sometimes, if a sphere is given like this, and if you want to find out only the small spherical shell in this one, if this radius is R, the thickness of this one is dr, the volume of this sphere, not the entire sphere, volume of this spherical shell only, only this volume is given by dV. Volume is V, students, volume, dV is small volume of this given sphere, small volume of this given sphere is given by, volume is area into thickness or area into height, area of this one is 4 pi R square and the thickness of this one is dr is very small thickness. So this is another formula to find out volume. If you take cylinder here, the cylinder can be drawn like this. This is our cylinder. The cylinder will have different radii or may have same radii. If the cylinder has different radii, then it is not a uniform cylinder. Here, even it is not mentioned, always you take this as uniform cylinder. For uniform cylinder, radius is constant. So here we are giving formulas for uniform cylinder. So here radius is R, at the bottom also radius R. Anywhere if radius is remains R, then it is called uniform cylinder. So now I am writing formulas for uniform cylinder. The first one, what is the area of this cylindrical portion? But area, we have three different areas, students, here. What are those three different areas? We will check. The first one, this is a circular area. Circular means for a cylinder, the top surface is a circle and the circular area is given by pi R square. Similarly, at the bottom also we have one more circle and its circular area is given by pi R square. And the next area, is this one, that is a lateral. So if you take this pen, this is called a lateral surface area. So the lateral surface area is given by lateral surface area is given by, this is circumference 2 pi r, height of this one is h. So we can write it 2 pi r into h. Now, if they ask you to find out the total area, so I am writing here, total area of a cylinder, we need to add these three, pi r square which is equal to 2 pi r square and next one 2 pi r h. So total area is given by 2 pi r plus h. This is the total area of a cylinder. But if you take the students, the total area of a cylinder, here it is given by 2 pi r into r plus h, And if you want to find out the volume of the cylinder, volume is given by, volume of the cylinder is given by volume of cylinder is area of the bottom, that is pi r square is the area, circular area into height h. So this is the volume of the cylinder. The next one, ellipse. For ellipse, we have ellipse which can be drawn like this. So this is an ellipse. For ellipse students, we have two different axes, semi-major axis, semi-minor axis. If you draw a line here and if you draw one more line here, one is along x-axis, one is along y-axis. The line which is along x-axis, this one is a major axis, and we denote this A, this is also A. So total length of the major axis length is 2A. Similarly, at the same time, if you take this one, this is B, this is also B. Minor axis is 2B. Now, if you want to find out the area of this ellipse, for it is almost seems to be a circle. For circle pi r square, here also area is given by pi r square. Which radius you have considered? We have considered both radii here. That's why instead of this, we will write pi AB is the area of an ellipse. Similarly, circumference of ellipse is given by 2 pi r. Here we can write 2 pi. This r is root mean square value of these two. That is a square plus b square by 2. So this is a circumference of the ellipse. Next one, if you take cone, this is a cone. In this cone, students, generally they would ask you to find out, this is the height of the cone. This is the height of the cone, this is the radius of the cone, and this is called slant height of the cone. Now in this case, to find out the area of the cone, we will write pi r into L, So pi is pi, r is radius, L is called slant height. Slant height is given by root over r square plus h square. So this is the radius r, this is height h, height of the cone h. Then area of this cone will become pi r into slant height, or pi r into root over r square plus h square. Then volume of this cone, and please remember, in a cylinder, the volume of one cylinder is exactly equal to volume of 3 cones of same radius, same height. That means if you take one cylinder here, if the volume of cylinder is 300 meter cube, so if you draw 3 different cones here, and each cone will have a volume of 100 meter cube. So volume of 3 cones exactly equal to volume of one cylinder. That's why volume of cone is 1/3 the volume of cylinder of same radius and same height. So volume of the cone is given by 1/3. Volume of cylinder is pi r square h. So we can write this as pi r square h. This area of the cone is lateral area. Suppose if they ask you to find out the total area of the cone, then I have to take the area of the base also. Then the total area of cone, is given by pi r into root over r square plus h square plus pi r square, and this will give the total area of the cone. This area of the cone is lateral area. Suppose if they ask you to find out the total area of the cone, then I have to take the area of the base also. Then the total area of cone, is given by pi r into root over r square plus h square plus pi r square, and this will give the total area of the cone. This side we will take it as A, and one more side is B. Opposite sides are equal, but this angle is not 90. This is one angle is less than 90, other one is greater than 90. That is acute and obtuse angles. So to find out the area of parallelogram, we have, this is similar to a rectangle only thing is here, if we draw one extended line here and draw a normal, and this will become a rectangle here. Area of rectangle is length into width, but here the extended area, this one is exactly equal to this one. That's why area is given by L into B only, but here L is equal to A, and this B is not this one, we have tried this H. So A into H. But if you see the student, in this triangle, this is B. If you take this angle as alpha, sin alpha is equal to opposite side H by this side is B. So sin alpha is equal to H by B. H is equal to B sin alpha. So this area of triangle can also be written as the parallel side or base of the parallelogram into height is given by B sin alpha. So this is the area of parallelogram. Now, if you take the trapezium, one side is A, parallel side, another parallel side is B. Height of this one is H. So in this trapezium, to find out the area, the formula for trapezium or trapezoid is given by area is equal to half into sum of the two parallel sides into height between the two parallel sides. This is height. So which is given by area is given by half into sum of the two parallel sides. In this is the first side, this is second side, both are parallel, but these two sides are not parallel, so we have to have only the two parallel sides, that is A plus B, into height H. So this is the formula to find out area of a trapezium. Now, if you take the triangle, let us say this triangle height is H and the base is B. Area of triangle is given by half into base into height, which is given by, simply we can write half into base is B, height is H. Similarly, sometimes they may ask you to find out the circumference of a triangle. Circumference is given by this side, and this side. If it is A, this is base B, this one C. Circumference is given by A plus B plus C, and we denote this a letter S. We have a relation between circumference of and area of this triangle. Area of the triangle can also be written as circumference of the circle into circumference minus first side. circumference minus second side, circumference minus third side. So this is also another formula to find out the area of this triangle. Sometimes we may have a right angle triangle, the base be height h. For this also area is given by half into base into height, and this hypotenuse is given by, I will take this as L. L is given by root over b square plus h square. And sometimes for the same triangle, for a similar triangle, for example, if you take equilateral triangle, that is A is equal to B is equal to C. A is equal to B is equal to C. Then to find out the area of this equilateral triangle, the general formula for finding area is going to be half into base into height only. Here half remains as half, base is A, and to find out the height for equilateral triangle, all angles are equal. All angles equal to 60 degrees each. This is 60 degrees. Now to find out h, we know the hypotenuse. Sin 60 is equal h by a. Root 3 by 2 is equal h by a. And the height is given by root 3a by 2. So which is equal to root 3 a square by 4 is the area of an equilateral triangle. And for isosceles triangle, where two sides are equal, if you take a triangle here, let us say this is A, and the base of this triangle is B. For isosceles triangle, if you know one of the value, let us say this is theta, and how to find this height. If you know this one, and we need to find out the same order here, half into area is given by half into base into height. Base B only. H. Once again we can use sin theta is equal to h by a, and place of h you can write a sin theta. So this is a sin theta. Here I have taken a container of length L, width B, height h. In this case, LBH is given. To find out the volume of this container is given by product of length into width into height, that is LBH. But surface area is given by, if you see this diagram, here we have the front surface, this which is nothing but a rectangle, and its area will be length L into height h. So surface area L into h. This is one surface. Other surface, this is B into h. B into h. Other surface, this one L into B. This is L into B. These are the three surfaces that are visible to us from this side. But behind we have rate, and we have one more surface, this one more surface, and at base one more surface, which are similar to the same thing. That's why this will be into 2 times. This is the total surface area of a rectangular container. Now, if you take a cube, both are similar. Only thing is for a cube, L is equal to B is equal to H is equal to some side. Let me take it as A. So this will become A, side A, and width A, and height is also A. Then volume of cube is given by, formula is LBH only. LBH, L is equal to A, width is equal to A, height is equal to A. The volume of the cube is given by A cube. Next, surface area of the cube. Here, if you observe this one, this surface is area A into A, this is A square. Second one, second surface, third surface, this side fourth surface, back fifth and bottom sixth. All surface areas are equal. The total surface area of the cube is into 6. So the total surface area A total is going by 6A square. So this is the formula to find out surface area of the cube, and the volume of the cube is going by A cube. Volume of a rectangle content is LBH, and surface area of this one is 2 into LB plus BH plus LH. We will discuss the graphs that are useful in physics. We have studied about these graphs in high school standard, sir. The first graph is y is equal to mx graph. So while drawing the graph, students, we know how to draw the graph. First we will take the table. And then we will write corresponding x and y values here. Let us say this is x, this is y. If you take x0, substitute this x0 here. If you take x0, and here m is the slope of the graph, and y will become any value. Slope may have any positive or negative or even 0 also. Let us say slope of a graph is in this case is m is equal to 2. Then this will become y is equal to 2 into 0, which is equal to 0. And y is equal to 2 into, let us say x is equal to 1, y will become 2. Suppose x is equal to 2, 2 2s are 4. Suppose x is equal to 3, we will write this as 6. Suppose x is equal to 4, we will get 8. So this is x value, this is x value, and the corresponding y value we have written here. So this is x and this is y. I will take this as x1, y1, this is x2, this is y2, this is x3, this is y3, this is x4 and y4, and please remember the slope remains constant. Slope is constant. Slope of this graph is constant, which is equal to slope m is equal to 2. Slope is to the letter m here. So now we will substitute these values. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 4. When x is equal to 3, y is equal to 6. When x is equal to 4, y is equal to 8. Suppose if you take x is equal to minus 1, y is equal to minus 2. X is equal to minus 2, y is equal to minus 4. Now we will draw the corresponding graph for this one. So this is your y axis, this is x axis. So in this case we will write this scale first. This is 0, 0, 1, 2, 3, 4, 5. Similarly, this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 3, minus 2, minus 1, 1, 2, 3, 4, 5, 4, 3, 2, 1. But here this is minus 1, minus 2, minus 3, minus 4, minus 5. This is an along negative y axis. Now the graph is first to represent these values, we will take first set. When x is equal to 0, y is also 0. This is the first point. X is equal to 0, y is equal to 0. Then when x is equal to 1, y is equal to 2. When x is equal to 1, y is equal to 2. So this is the corresponding point. When x is equal to 2, y is equal to 4. When x is equal to 2, when x is equal to 2, along this side, y is equal to 4. Similarly, when x is equal to 3, y is equal to 6, somewhere here. Similarly, when x is equal to 4, y will become 8 at top. And x is equal to minus 1, this is minus 1, y will be minus 2. When x is equal to minus 2, y will be minus 4. So this is the corresponding graph, students. Now, if you take this line, and if you want to join these, and finally you will get a line like this. Here it is passing through the origin, and the slope of this graph is given by, this is called slope. The slope of this graph is given by theta, and tan theta is the slope. We denote this as m. If you take this, students, in this triangle, if you take this triangle, any one triangle here, how to find tan theta? Tan theta is opposite side, which is equal to 4. Corresponding side is 2. So this is 4 by 2. So slope of this graph is given by 2. Not only this triangle, even if you take the another triangle, this is 6 by 3. Once again, you will get 2. And if you take 2 by 1, you will get 2. Even here, if you want to find out, the slope will remain constant. So slope is always 2 here. So from this we can write y is equal to mx graph with the m is equal to 2. And always remember, the slope is measured from x-axis from the given graph. This is the given graph. This is the given graph which is passing through the origin. This is always measured in anti-clockwise direction from x-axis. So slope is measured from x-axis in anti-clockwise direction. So here, when we are measuring this slope of this green color line, this graph from x-axis in anti-clockwise direction, the slope will be less than 90. We know less than 90 theta, we call this as acute angle. So slope is said to be positive slope. Suppose if the graph is like this, then the slope will be, theta will become obtuse, then the slope will become negative because the angle goes into the second quadrant where tan theta is negative in second quadrant. That's why slope is said to be positive if theta is less than 90. Theta less than 90, slope of the graph is positive. Similarly, theta greater than 90 degrees, slope is negative. Equation for the graph mx plus c, and it is similar to the previous case where y is equal to mx. Y is equal to mx is a graph passing through origin. Whenever y is equal to mx is given, that is a straight line passing through origin. Now, if you take this y is equal to mx plus c, and here to draw this graph, students, we have different cases in y is equal to mx plus c. This is the first y axis, this is x axis, y axis, x axis, another y axis, another x axis. So we have taken three different graphs here. In this, the first graph is shown like this. Let me change the color here. Here, this is the graph of time. Here, this is the graph of time. And here, This is the graph obtained. We have three different graphs here and we will discuss about each graph in detail now. The first one, this point is called intercepting point. So this is y-intercept. Here constant is y-intercept. And what about the slope of this one? We can find out the slope here. This is theta and the slope of this one is tan theta. And by looking this graph, we can say that this here theta is less than 90 degrees. So this graph, this is, I will take this as first graph. In the first graph, slope m is positive. Slope of the graph is positive and y-intercept, so as it is origin, this is y-axis, so here positive y-intercept. So slope is positive and y-intercept is also positive because this graph is intersecting y-axis at a positive value. This is 0, plus 1, plus 2, plus 3 like that. So C is also positive. Now you see this graph, students. This is the slope theta. So here theta less than 90 degrees. We can say m is slope of the graph is positive here. Second one, this graph is intersecting y-axis at a negative value because this is origin 0, 0, minus 1, minus 2. So C y-intercept is negative here. Third one, if you observe this diagram. This is the y-intercept, this is a y-intercept, and we can say this y-intercept is positive because this is above origin, and the slope here we have to measure from x-axis in anti-clockwise direction. This theta is greater than 90 degrees, so slope is negative, but y-intercept is positive. And one more is there. The graph is given like this, and this is x-axis and y-axis, but the graph is given like this. In this case, slope is negative, m is negative, as well as y-intercept is also negative. So these are the four types of graph. And please remember, whenever y is equal to mx is given, students, y is equal to mx graph always passes through origin. Y is equal to x always passes through origin. If x value is doubled, y value also doubled. X is made 10 times, y also made 10 times because here we can say y direct proportional to x. But here we cannot say like that because we have an intercept. So direct relation is not there. So but still it is a straight line. Y is equal to x plus c, where y is y coordinate, m is the slope of this one, and this is the y-intercept. To take these graphs now, first one y is equal to mx. To draw this graph, students, what we are going to do, this y is equal to mx plus graph always passes through the origin. Now, if you take this graph, first one, like this, one more graph like this, one more graph like this. And in these graphs, we can observe that here m is positive and c is also positive. The corresponding equation for this one is y is equal to plus mx plus c. Next one, if you take this one, this is theta greater than 90, here theta less than 90. So here m is negative, but c is positive. The corresponding equation for this graph is y is equal to minus mx plus c because slope is negative, more than 90 up to angle. And the next one, if you take the fourth graph, here how to measure the angle always from x-axis in the anti-clockwise direction. theta greater than 90. So slope m is negative and the y-intercept c is also negative. So from this the corresponding equation will become y is equal to minus mx minus symmetric parabola about positive x-axis, and here we will write a symmetric parabola about negative x-axis. For these students, the corresponding equation here is y square is equal to plus kx. For this one, y square is equal to minus kx. How to draw the graph? So this graph, whenever this equation is given, it always represents a parabola. Y square is equal to plus kx or y square is equal to minus kx. That means in the previous graph you could see y is equal to mx. Here y power is 1, x power is 1. When these powers are equal to 1, it is a corresponding graph is always a straight line graph. And if it is c, then it is not passing to the origin. If it is just y is equal to mx, it is passing through the straight line passing to the origin. But for parabola, please remember y square is equal to plus kx power 1. Here y power 1, x power 1, it is a straight line. Y power 2 and x power 1, then it represents always a parabola. And it is symmetrical parabola about x-axis. We will see this is x-axis, and we will draw the graph for this one. For this graph, first let me take one table, students, by taking x and y values. The equation for this symmetric parabola about positive x-axis is y square is equal to kx. So first let me take some y values here. First x0, x plus 1, 2, minus 1, minus 2. As it is only about positive x-axis, so we have to take only the positive values. So I will write only about positive x-axis. So I will take only the positive values. So let me take 3 and 4. Why? Because this is a symmetric parabola about the positive x-axis. So I have to take only positive values. And if we substitute this value here, what you will get, you will see y square is equal to kx is the given equation, and k is a constant here. So y square is equal to k into 0. K is a constant, k into 0 is 0, y square 0, so y is 0 only. Now y square is equal to k into 1, so this will become root k, because y square is equal to k, y is equal to root k. Suppose if you take y square is equal to k into 2, x is equal to 2, so then this is a y value. Here y value will become root 2k, and if x is equal to 3, this will become y is equal to root 3k when x is equal to 3. If x is equal to 4 into k, y square is equal to 4k and y is equal to root 4k. So these are the values. Now on this x-axis, students, we will take x0, x1, 2, 3, 4 and the corresponding values on y-axis. And this is root k, root 2k, root 3k, root 4k. And if you observe this one, this is nothing but 2 root k. This is 1 root k. This is 1.414 root k. 1.732 root k. So that means this is 1, this is 2. Now we will write this is a y-axis and 2k, this is 1k. Now actually we have to write 2 root k, this value 2 root k, 2 root k. This is 1 root k. Now, when x is 0, y is 0. So that the first point, first setup, x is 0, y is 0. And when x is equal to 1, y is root k. This is the point. X is equal to 2, y is root 2k. Root 2k means 1.41k. This is 1.1. So this is the point. And y is equal to x is equal to 3, y is root 3k. X is equal to 3, y is 1.732, somewhere here. This is 2, this is this. And if you observe this one, the pattern, if you add this, the smooth curve, this is called parabola. But at the same time, students, if you take this one, y square is equal to k into 1 which is equal to k. Y square is equal to k. Y is equal to plus or minus root k. So this value not only positive, it may be negative. So this is plus or minus 1, plus or minus root 2, plus or minus root 3, plus or minus root 4. For the same value, you may get another set of values here, which are like this, and you will get a curve like this. That's why this is symmetrical about x-axis. That's why it is called a symmetrical parabola about x-axis. Is always y square is equal to plus kx. And what about y square is equal to minus kx? Suppose if we take x is equal to 0 for the same setup we are drawing, this is x and y. When x is equal to 0, y should become 0. When x is equal to, as it is around negative x-axis, I will take minus 1, minus 2, minus 3. So x is equal to minus 1, minus of minus plus. So this will become y is equal to minus k into minus 1. This is y square is equal to k, and y is equal to plus or minus root k. And x is equal to minus 2 plus or minus root 2k. And minus 3, this will become plus or minus root 3k. Now from this data, we can draw the corresponding graph here. When x is equal to 0, y is equal to 0. First let me take these values. As we are drawing a symmetric parabola about negative y x-axis, so I am taking negative x values here, and the corresponding minus 1, minus 2, minus 3, 1, 2, minus 1, minus 2, minus 3, 1, 2, 3, like this. The next value, when x is equal to minus 1, this is minus k, and x is equal to minus 2 root 3. So the corresponding graph will be like this, and you can see this is above negative x-axis, and the corresponding, because it is also negative value, so negative 1. So this is the parabola, symmetric parabola above negative x-axis. If you observe this one, why it is called symmetric? Because the upper portion, this one, is similar to the lower portion. That's why these are called symmetric parabolas. Y square is equal to kx will be like this, and y square is equal to minus kx will be reversed. X square is equal to ky is also a symmetric parabola, but this is x square is equal to ky about positive y-axis. About positive y-axis. That is, the graph will come like this. So the graph will be symmetrical about positive y-axis. Similarly, if you take this one, students, the next one, x square is equal to minus ky, this is also symmetric parabola about negative y-axis. But if I can see this one, we can say whether it is a symmetric about this one or x1. So here it is on right side we have y. So this is a symmetric about negative y-axis. So the corresponding graph will be like this, and it will be symmetrical about negative y-axis. Now, what is this asymmetric? Here it is symmetric. And the right side and left side will be same. Here right side and left side will be same. Symmetric. But if we take as equation y is equal to ax plus bx square. Here also you can see y power is 1, x power is 2. And we have one more term which is x power 1. For these students, the graph will be like this. So this is a left side we won't get any parabola. So this is y is equal to ax plus bx square and its graph control like this. Similarly, if you take this one, most important one, and we are going to use this so many times in first PUC itself, y is equal to ax minus bx square. This is asymmetric. Parabola. This is not symmetric, asymmetric parabola. This is also asymmetric parabola. And when we are getting negative here, powers 1 and 1, you will get a curve like this. And this is most important. Whenever a body thrown into air, it moves in this path, and this is called asymmetric parabola path. Not only this one, even if you take volleyball, football, and football is kicked, then it moves in a path, and that path always represents this parabola, and this parabola is not symmetric, this is a asymmetric parabola. The first one, rectangular hyperbola graph. Students, whenever the product of two physical quantities is always constant, then the corresponding graph is always rectangular hyperbola. So two physical quantities, let us say xy are constants. Xy product is constant. Now, I am taking x-axis, x coordinates along x-axis, y coordinates along y-axis. The corresponding graph will be like this. This is rectangular hyperbola. And we have some examples for this one, students. Force is equal to mass into acceleration. Let us say force on a body is constant and equal to 10 Newton. Now, if you draw the graph for this one, mass and acceleration, force is always 10. The product of these two always 10 Newtons only, always 10 Newtons. Then, suppose mass of body 1, acceleration 10. Yeah, 1 into 10 is force 10. Suppose mass of the body is 10, acceleration will become 5, but product of these two is 10. Acceleration of the body is 2, mass will become 5, product of these two will be 10. Suppose mass is half, this will become 20, 20 into half is also again 10. For such values, the product of these two always constant. Suppose if you take mass along x-axis, acceleration along y-axis, we know product of mass and acceleration is always constant equal to 10 Newtons. For such graphs, we will get a rectangular hyperbola, and in most of the competitive exams, this one formula or this method or this graph is very, very useful. Please remember, if two physical quantities, physical quantity 1 inversely proportional to physical quantity 2, the corresponding graph is always a rectangular hyperbola. In boils also, you might have studied this in the school standard. Pressure of a gas inversely proportional to volume at constant temperature. So when the pressure increases, volume decreases. Suppose if you take pressure here, volume here, then also it is a rectangular hyperbola. So whenever a graph is given such that two physical quantities are inversely proportional to each other, the corresponding graph is always a rectangular hyperbola. The corresponding graph is always a rectangular hyperbola. So this is very, very important, and you have to remember it for a long time. And please remember, this is given in our Karnataka flag colors. That's why this is most important. And please remember this one. Whenever two physical quantities are inversely proportional to each other, the graph is always a rectangular hyperbola. Then we have circle when you are drawing a circle, students, and this is our circle, in this case, if you observe this one clearly, along x-axis I am taking something, and we know that something, this is called radius, and along y-axis also, this is also radius only. So the corresponding equation for circle is x square plus y square is equal to a square, and this is a constant. And if you see this one, x square plus y square is nothing but r square. If you take any value, suppose x is 0, x and y values, if you take x is 0, now keep this 0 square plus y square is equal to this r square, that means y is equal to r. So when x is equal to 0, y is equal to r. Similarly, if you take y is equal to 0 and substitute in the same equation, x square plus 0 square is equal to r square, and x will become r. So if you take this point, here x is equal to r, it is on x-axis, so we can say y is equal to 0. So this is y is equal to 0 and x is equal to r. Similarly, if you take this point, here x is equal to 0 and y is equal to r. So the circle equation is x square plus y square is equal to a square, or you can also write this as x square plus y square is equal to r square, where r is the radius of the circle. Now, next one, ellipse. For an ellipse, we can say, for an ellipse, if you draw the ellipse properly, and we have two different values in an ellipse. First one is semi-major axis. From here to here, this is major axis, this is only half of it, we call it as semi-major axis, and this is called semi-minor axis. And the corresponding equation for ellipse is, this is along x-axis, this is along y-axis. So x square by a square plus y square by b square is equal to 1. And if you observe this one, here x is equal to a, and if you substitute a here, a square by a square. And here on x-axis, that x is equal to a, y will become 0. So 0 square by b square is equal to 0 by anything is 0, a square by a square is equal to 1. So this is how we can prove this ellipse equation. So ellipse equation is x square by a square plus y square by b square is equal to 1. And then the next one, exponential decay, exponential curve, which is given by y is equal to e power minus kx students, and this curve will be like this, and it continues to decrease. It never becomes 0. Actually, it will become 0 at infinite distance. So these are called exponential decay. Decay graph. Similarly, we can draw exponential growth also in such problems. This will be a straight line, and it will become that the magnitude, it will reach the maximum value at a great value, at a great time, or great x value. So for that, equation is y is equal to e power something into x. So this is a graph between y and x only, but exponential decay, when negative is there, this is decay. When y is equal to e power kx is there, this is for growth.